Gravity. What is it? First, to understand gravity, we need to understand force. A force is a push or pull on an object. It is a pull or a push on an object. Gravity is a natural force that pulls on all objects toward the center of the earth. Sir Isaac Newton concluded that a force acts to pull objects straight down toward the center of the earth. Gravity is a force that pulls objects toward each other. Newton's idea was that gravity was a universal force acting between any two objects. This is the law of universal gravitation. The idea that the earth pulls on you, the earth pulls on the apple pulls on you pull on the apple, the moon pulls on you pull on the moon pulls on the earth pulls on the moon, and all of the others. Newton knew that the gravitational force on the apple is equal to the apple's weight in milligrams, where gravity is equal to 9.2 meters per second squared. Newton reasoned that the centripetal force of the moon was also supplied by the Earth's gravitational force. So the fact that the moon revolved around the Earth was due to Earth's gravity. Newton's calculations showed that the centripetal force needed for the moon's motion was about 1 over 36 thousandths of a milligram, however, where the mass of the moon, where m is the mass of the moon. Newton's calculations showed that the centripetal force needed for the moon's motion was about 1/36,000th of mass per grams, however, where the m is the mass of the moon. Newton knew, though, that the moon was about 60 times further from the center of the Earth than the apple. And 60 squared is equal to 63,000. And 60 squared is 3,600. So what is universal gravitation? The force of gravity acts between all objects in the universe. Any two objects in the universe are attracted to each other. From this, Newton reasoned that the strength of the gravitational force is not constant. In fact, the magnitude of the force is inversely proportional to the square of the distance between the objects. All of this, actually, we're talking about the closer they are, the more attracted they are, and the further apart they are, the less attracted they are. Newton concluded that gravitational force is directly proportional to the masses of both objects and inversely proportional to the distance between the objects. So in symbols, Newton's law of gravitational is F is equal to G, mm over r squared. So what would happen if you dropped a marble and a bouncy ball at the same time from the same height? They fall at the same rate of speed, but the marble has more mass, meaning it has more weight because gravity pulls on it more. So gravity makes it fall harder. Gravity has a stronger force on things with more mass. It takes a force to overcome gravity. Throw a beanbag in the air and then throw a basketball in the air. Which one was harder to throw? you had to use more force to throw the basketball because it has more mass. What are the factors affecting gravity? Well, the two factors that affect gravitational attraction between objects are mass and distance. Mass is a measure of the amount of matter in an object. Now, the more mass an object has, the greater its gravitational force. So the sun's mass is so great that it exerts a large gravitational force on the planets. This is one reason why they stay in orbit. Now, distance, the further apart two objects are, the less gravitational force between them. So how are weight and mass related? Well, mass is the measure of the amount of matter in an object, and weight is a measure of the gravitational force exerted on an object. So weight varies with the strength of the gravitational force, but mass does not vary at all. So your mass, if you weighed 120 kilograms in mass, you would take your weight and multiply it by gravity. Here on Earth, that would be 10. So you would weigh 1,200 newtons. But on the moon, you take your mass, and your weight would only be 200 newtons. So how does air resistance affect gravity? Well, air resistance increases with velocity. Eventually, the falling object will fall fast enough that the upward force of air resistance is equal to the downward force of gravity. At this point, the forces are balanced and the object stops accelerating. The object will continue to fall at a constant speed. This is called terminal velocity, when the force of air resistance is equal to the weight of the object. What this means is if you drop something out of an airplane, it'll continue to gain speed and accelerate until the air resistance balances it out. And at this point, you've hit terminal velocity, when your air resistance is pushing up and the weight of the object and gravity pulling it down are equal, and you stop gaining speed and fall at a constant speed called terminal velocity.